Alright guys, we're going to do objective 28 today. We are going to graph rational functions, and we're also going to be able to determine the horizontal and vertical asymptotes, domain, range, and holes in a graph. So we're going to have a list of 5 things. Those 5 things for each graph, so we're going to graph them, and then after we graph each one of them, we're going to list the vertical asymptotes, the horizontal asymptotes, the domain, the range, and the holes. Okay, so we'll have a list of H, A, V, A, D, R, and H, okay, on each graph. I highly recommend, as we get started, that you might want to use a colored pencil or a highlighter as we graph these, because it will be very beneficial for you to mark your asymptotes in a color so that you can then see your function, okay, a little bit better, and you'll be able to determine your asymptotes just a little bit better. So, the definition of rational. We know rational means what? Rational means fraction. So, a rational function is going to have a variable. It's going to be a fraction, but it's going to have variables in the top and the bottom. Okay, it's going to have variables in the top and the bottom. So you're going to have a function in the numerator and a function in the denominator. Let's talk about this weird word, asymptotes. Everybody kind of giggles when I say that. Asymptotes. Okay, asymptotes are defined as a line that the graph approaches. We will study vertical and horizontal asymptotes in Algebra 2. There is something called an oblique or a diagonal asymptote, but we won't worry about those in Algebra 2. You can get to those when you get into higher level math. So for Algebra 2, we're going to simply look at the vertical asymptotes and the horizontal asymptotes. Okay, so it's a line that the graph approaches, meaning it's going to get really, 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 really close to that line, but it's never going to cross it. It's never going to touch it, okay? It's going to get really, really close to that line, but it's never going to cross it. All right, I know you're thinking, oh, look at all these rules, but I'm going to give you a couple seconds. You might want to hit the pause button and copy this down. But let me read through them first. And you definitely need to have these rules down because you're going to come back and look at these rules. Okay? So to know if it has a horizontal asymptote, you got to look at the degrees. If the degree of the numerator, a of x is in the numerator, if the degree of the numerator is greater than the degree of the denominator, then there are none. There are no horizontal asymptotes. Okay? If the degree is bigger in the numerator than it is in the denominator, then there are none. If the degree of the numerator is less than the degree of the denominator, and when I say degree, guys, I'm talking about the highest exponent you see. Okay? Like a degree of 1 means you see x to the first power. A degree of 2 would be you see x to the second power. It's the highest exponent you see. So if the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote will be y equals 0. If the degree of the numerator equals, if they are matching, the degree of the numerator and the denominator are equal, then it's their coefficients. It would be the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, so I'm going to hit the pause button, or you hit the pause button and finish copying this down, and hopefully you're back with me now, and we're going to roll on. So let's talk about the rules for vertical asymptotes. It's a little bit simpler. It's when the b of x, now where's b of x? B of x is in your denominator. It's what makes your denominator 0. Okay, and we've already done this a whole lot. We know it's undefined. Okay, it's undefined. And what kind of line is undefined? A vertical line has an undefined slope, and it's what makes it equal to 0. You cannot have a 0 in the denominator. So this one's going to feel a little more like home because we've addressed it, but you have to look at the denominator. Okay, what makes the denominator 0? Okay, and let's talk about wholes real quick. Wholes, we call it point discontinuity, meaning it's where your line is not continuous. It looks like a hole in the graph because the graph is undefined at that point. Now, vertical asymptotes and wholes are very similar because they both are undefined at that point. We will talk about the difference in a minute when we get to examples of how do you know if it's a hole and how do you know if it's a vertical asymptote. Okay, but it's all what makes the denominator 0, and it's points that are undefined. But there is a difference. One will make a hole, and one will make a vertical asymptote. And we'll talk about that when we get to an example. So let's look at example 1. Okay, the first thing we're going to do is we're going to make our list. I'm going to put HA, VA, that's for horizontal asymptote, vertical asymptote, domain, range, and holes. Okay, and we're going to do that on each one. So the first thing that we're going to do is in our colored pencil, so I'm going to pick a color. Let's do red, because red seems to show up. We're going to determine our horizontal asymptotes. Now, we need to go back to that rule sheet for horizontal asymptote. It has to do with the degree of the numerator and the denominator. So in this case, degree meaning what is the highest exponent I see. The highest exponent I see is 3 in the numerator, because that's the exponent. And the highest exponent I see in the denominator is 1. Now if you go back to the rule sheet, what does the rule sheet say? It's bigger in the numerator. So let's go back to that rule sheet. And the rule sheet says when it's greater in the numerator, a of x, then there are none. So we know that we have no horizontal asymptotes for this. Okay? So I'm going to just write none. So you don't have to draw anything yet. Okay? Vertical asymptotes have to do where it's undefined. Okay? Where is this undefined? What would x be? And it's all what makes it equal to 0. We have a vertical asymptote at x equals 1. Because if I plugged 1 right here, that would make that denominator 0. And that's where it can't be that. That's going to be undefined. So in my color, I'm going to take my red. Right here at x equals 1, that's where x equals 1, I'm going to do a little dashed line. And that's going to be your horizontal asymptote. Okay? Okay. So, at this point, we are going to put this into our calculators. Okay? Make sure you put parentheses around the numerator and the denominator, and you're just going to sketch it. Okay? So, I'm going to click through this card, and let me pull up my calculator. Let's go to this first example. Alright, so I'm going to go to y equals, I need to clear out everything, and I'm going to put parentheses around the numerator, so x raised to the third. Oops, let's go back. Don't forget to delete that. Don't forget to arrow down, x raised to the third, divided by parentheses x minus 1. Oops. X minus, close parentheses. There we go. And I'm going to graph. Okay. Now, we have this. If I go back to my color. Go to red. So, first of all, I have this asymptote right here, and it came on black. I apologize for that. I like it to be in a different color. Let's see if I can get a different color. My color wheel's not working. So I think I'm going to have to keep the same color, but I'd like for you to do it in a different color. So if you try to sketch this, this is what it's going to look like, okay? If you sketch this, it's going to come down and it's going to look something like this, and it's going to get awfully close to this asymptote, but it's never going to touch it, okay? If you look to the other side of it, it's going to look, oh look, now I can get my color. I don't know why it's doing that, but maybe I should do this. Here's the function. It went back to the other color. So it's going to come from this side, and it's going to dip down, and it's going to get awfully close to this asymptote, but it's not going to quite touch it, okay? So you have this asymptote right here, and I'm going to go ahead and click back to, so I can get my colors on here. You have this asymptote right here, and this is the line where the graph's approaching, okay? So when you graph it in your calculator, it's going to graph, and it may not look exactly like that, but you can just sketch it. But it's getting really close to that asymptote, but not quite touching it, okay? If we come back to our list, HA, VA, domain, range, and holes, we said that there was no horizontal asymptotes. You've got a vertical one at x equals 1. Your domain, okay, let's talk about domain a little bit. You learned domain in Algebra 1. Domain is known as the x values, okay? They are the x's, and range are the y's, okay? X's run left to right, and y's run up and down, okay? You need to understand that. So if we talk about our domain, if I started over here on the left side of the graph, how far does this line go? Okay, it's going up, but it's also coming like at an angle. So it covers everything to infinity. Like it's going forever this way. Okay, it's also going, even though this is going up on this side, it's going at an angle. It's going forever this way. Okay, but where does the blue or black lines not hit? There's a certain number that it doesn't hit, and that's your asymptote. It doesn't ever hit this line right here at x equals 1. So if I wanted to describe my domain, I would say it's forever to negative infinity. That's where this is, negative infinity. And it's forever this way. Okay, these lines are going to cover forever, 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 that way. Okay, but it doesn't cover 1. So you would write it like this. You would say all x's except or such that x cannot equal 1. Okay, it can't be 1. Okay, because that's where your asymptote is. Now, if you look at your range, let me go in green, how far down does this graph go? Forever, that's to negative infinity. How far up does this graph go? If you look at all these arrows, it's going forever up. My question is there like a crack in the graph? Sometimes I call the asymptotes like a crack in the graph. Is there a spot going up and down that it can't be, that it skips over? Okay, and there's not. So you could say that your range is all real numbers. It's every number up and down. Okay, it's every number up and down. Now, because we have a vertical asymptote, we do not have any holes. And I'm going to tell you the holes and vertical asymptotes are similar. They both make the denominator 0. But here's the thing. If something cancels in your function, Like if this x minus 1 would cancel, then 1 would be a whole. If it doesn't cancel, then it's a vertical asymptote. Okay, and because x minus 1 does not cancel with the x cubed, then it's a vertical asymptote. Okay, if it cancels, it's a whole. But if it doesn't cancel, it's a vertical asymptote. Okay, and it'll make more sense when we get to an example that actually does cancel. So let's keep going to example 2. Okay, so the first thing you need to do is you need to factor. It's always got to be simplified. So I'm going to factor this guy right here into x and minus 3 and plus 2, I believe. And this will be x plus 1. Okay, so let's make our list. HA, VA, domain, range, holes. All right, so let's go back to our rules. What's the highest degree you see up top? I see a 2, I see a 1, and this guy, there is none, so he has a degree of 0. So I'm just looking at the biggest. So the biggest is 2. I have a 2 up top. Okay, what's the highest degree I see in the bottom? I see a 1. Okay, I'm looking at the exponents. So if it's bigger in the top than it is in the bottom, we learned earlier that it's none. That you have no horizontal asymptotes. Okay. Vertical asymptotes, it's what makes it undefined. Okay, what can x, you got to look at the denominator, what can x not be? X cannot be negative 1. So that means you have a vertical asymptote at x equals negative 1. And you know this is not a whole. My question is when you factor it, does anything cancel? Does x plus 1 cancel with x minus 3 or x plus 2? And it doesn't. If it canceled, it would be a whole. But because it doesn't cancel, it's a vertical asymptote. So we know this is none down here. Okay. I'm going to go in red and I'm going to draw in my vertical asymptote. So in my colored pencil right here at x equals negative 1, I'm going to draw my vertical asymptote. Okay, that is where the graph is going to get really close to this line, but it's not going to quite touch it. So we're going to go to our calculators and we're going to put this in. And you can put this one in or you can put the original in. Just make sure you put parentheses around the numerator and the denominator. Okay, so if you've put this into your calculator, you're going to see something like this. It's going to come from this side, and it's going to get really, really close to this red line, but it's never going to quite touch it. Okay, same thing, it's going to come from this side, and it's going to get really, really close to this red line, but it's never going to touch it. Okay, so let's talk about domain. Domain are your x's, and they run right to left. So let's talk about, I'm going to start over here on the left side. How far left does that arrow go? He's going forever. Okay, so I'm going forever in that direction. How far to the right? Forever. My question is, as I start on the left side and I come across, does it have, think of like a, I always think of the saying, you know, don't step on a crack, you break your mama's back, like when you did when you were in elementary school. My question is there a crack in our graph? Is there a place where I have to hop over? And there is. When you get to this spot right here, you have to hop over your asymptote to keep going, okay? So my function is everything to the left of negative 1 and everything to the right of negative 1. So we got to say that our function is all x's such that x cannot be what? What can it not be? It cannot be negative 1 because that's where your asymptote is. Okay. Notice you can use your vertical asymptote to help you with your domain. And you can use your horizontal, like these are your restrictions. So, like, do I have any horizontal restrictions? So as I go up and down for my range, let me go with the blue. So how far down? Like, you can look at both of these arrows. It's going down forever. How far up? It's going up forever, because you can look at this arrow. Okay, you can even look at this arrow. It's going up and up and up and up and up. My question is as I start at the bottom and go to the top, is there a crack that I have to jump over? Is there an asymptote? And there's not. So we would say that our range is all real numbers. It's everything, okay? There are no restrictions. There are none. So that means it can be every number. Okay? So the first thing you need to do is you need to make sure, always factor it down first. Okay, you got to factor it down first. So x plus 2 over 2 times x plus 3. Okay, let's make our list. HA, VA, domain, range, holes. Okay. All right, let's go to our HA first, our horizontal asymptote. And let's look at the rule. What's the highest degree up top? 1. What's the highest degree down on the bottom? 1. So when they're equal, if you go back to that list, like if I click back to that list, what does it say if it equals? It says that y, your horizontal asymptote, would be the leading coefficient of the numerator divided by the leading coefficient of the denominator. So let's go back and look at that. So the leading coefficient of the numerator, that means the one in the very, very front, is a 1. So it's going to be y equals the leading coefficient of the numerator, which is 1, divided by the leading coefficient of the denominator, which would be 2. So that means if I go to where y is a half, and I draw my red line, half is in between 0 and 1. So I'm going to draw a line right here where y is, you are up a half, in between 0 and 1. Okay, that is going to be your horizontal asymptote. Okay, your vertical asymptote, it's what makes the denominator 0. What can x not be? Okay, and again, you have to have it factored to be able to do that. So x cannot be -3. So I know x is, you have a vertical asymptote at x equals -3. Okay? And I know it's not a whole because it doesn't cancel. Okay? X plus 2 and x plus 3 do not cancel. If it canceled, then it would be a whole. Okay? So I know this is none. So I'm going to go with my colored pencil. I'm going to go where x is -3, which is right here. And I'm going to draw my vertical asymptote. Okay, and then I'm going to take a minute and I'm going to put this in. At this point, let's graph it. Okay, let's put it in our calculator. Just make sure you put parentheses around the numerator and the denominator. And again, you can put in this one, you can put in the factored version or the original. It doesn't matter. All right, if I graph this in my calculator, it's going to look something like this, meaning it's going to have 2 asymptotes, meaning it's going to come down like this and approach the horizontal red line, but again, never quite touch it, and then it's going to curve up, and it's going to get really, really close to this other asymptote, but it's never going to touch it. Same thing here, it's going to get close to both of these lines, but never quite touch it, okay, because that's what asymptotes are. Okay, they're just points on the graph where the graph is approaching. Okay, so let's talk about domain. Domain are our x's, and x's run right and left. So let's think about this. How far to the left does this go? This goes forever, because you can look at that arrow. How far to the right? You can look at this arrow. It goes forever to the right. But as I start from the left and I'm traveling across the graph, is there a point where there's a break in the graph? And there is. It's right there, okay? And then I keep going. So you would say it's all x's except x can't be what? Where's the crack in the graph? At -3. That's where it's undefined. Okay? Your range is your y's. It's your up and down. Y's run up and down. So how far down? You can look at that arrow. It goes forever down. How far up? You can look at this arrow, forever up. As I travel, let me do this in purple. Start at the bottom or the top, and I'm going up. Do I hit a crack in the graph? And you do. It's right here, okay? And then you can keep on going up. So you got to like jump over the crack. So you would say all y's, you got to use y for range, except y cannot be what? Y cannot be a half, because that's where your asymptote is. Okay, notice again, your vertical asymptote, you can read it. You can use your vertical asymptote for your domain. You can use your horizontal for your range. Okay, so let's look at example 4. First thing I'm going to do is I'm going to factor this. So let's factor this into well, if I can get it to write, x and x, and I'm going to do +5 and -1 over x plus 5. I'm going to make my list to HA, BA, domain, range, holes. Okay, let's look at our rules for our horizontal. Okay, what's the highest degree? I see a 2. What's the degree in the bottom? I see a 1. So when it's bigger in top than bottom, the rules say none. Okay. Let's look at our vertical asymptote. It's what makes the denominator undefined. What makes it equal to 0? So what can x cannot be -5? Now, my question is that a vertical asymptote or is that a hole? This one is a hole, and the difference is when you factor this, these could cancel. Because these cancel, that makes x equals -5 a hole. Okay, meaning it's not a vertical asymptote. Okay, it would make it a hole. So if you graphed this, I believe it would look like this. You can put this in your calculator. But when you get to 1, 2, 3, 4, 5, when you get to, that's -4, there is a hole in the graph right there, meaning there's a point at where it's undefined. And you can even draw your red line if you want to, okay? It's not really a asymptote, but it's where it has to jump over that line right there. So if you graph this, and you're not going to see this in your calculator, that's why it's important. Like, you've got to understand what makes a hole. You're not going to see the hole in your calculator. Okay, I mean, if you sat there and wanted to play with your calculator and zoom in and zoom in and zoom in and zoom in on that spot, you would see the break in the graph, but it would be really hard to do that. Okay, so it actually, if you zoomed in, it would look something like that on a calculator. Okay, it would just be a break in the graph. Okay, we call that a point of discontinuity, where it's not continuous. So my question is, so we know that there's a little hole right there. Let's look at domain. Okay, so how far, that's your x's, x's run left and right. So how far to the left does he go? He goes forever. How far to the right does he go? He goes forever. But my question is there a break in the graph? And yes, there is. So it would be all x's except x cannot be -5. Okay? And range is the same way, except it's your y's and goes up and down. How far down does he go? Forever. How far up does he go? Forever. But this is -1, -2, -3, -4, -5, -6. This is down -6. So it's got to skip over that point. So you would have to understand that it would be all y's except y cannot be -6 because that's where the hole is. That's that point. That point, you got to kind of estimate that point. That point is -5, -6. Okay. Okay. Um, I think I'm going to stop right here for right now just because the video is getting awfully long. And I think we'll use these examples as warm-ups um, when we get back to class on Friday.